Hello students, and welcome back to another algebra video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, so you might notice that it seems like maybe we're taking a little step back in the example. This example is not exactly like the problems that we did in last video, because we did a lot in last video. So we're going to do a little piece of what we did in last video. We also did this in the first part of section 3.3, but I thought it would be a good review for what we're going to do today. So this question asks us to evaluate the function when x is 4, x is 0, and x is 3. So there are three parts to this problem. A part where x is -4, a part where x is 0, and a part where x is 3. So we want to plug each of these values into our function and see what we get. So f of -4, let's do that one first. So we have 2 times -4 minus 5. 2 times -4 is -8. Minus 5 is -13. And there we go. F of -4 is -13. All right, next we'll look at f of 0. That's 2 times 0 minus 5. 2 times 0 is 0. And 0 minus 5 is -5. Okay, last, we want f of 3. So we have 2 times 3 minus 5. 2 times 3 is 6. And 6 minus 5 is 1. So there you go. F of, or when x is -4, we get -13. When x is 0, we get -5. And when x is 3, we get 1. Okay, wonderful. Let's go ahead and move on to what we have for today. Today, we start our work on section 3.4, which is actually about graphing linear equations in standard form. So, our learning target is that you know what is a linear equation in standard form. So, you're going to learn what standard form is and what linear equations in standard form look like. Our success criteria is that you can graph linear equations in standard form, and you could graph equations of vertical and horizontal lines. Okay, so first, without further ado, what on earth is this standard form we keep talking about? So, standard form of a linear equation is a linear equation written in the form ax plus by equals c, where all these capital letters A, B, and C, these are just numbers. So we could have -2x plus 3y equals -6. We could have 5x minus 4y equals 1. We can have whatever we want as long as A, B, and C are real numbers. Okay, so you have heard we talked about how all lines, all linear functions can be written in the form y equals mx plus b. Now, this is a certain form. It is different than standard form. Both of these forms are the equations of lines. Today, we are focusing on standard form. ax plus by equals c. This form can be very helpful for graphing, and you're going to see how in a couple examples. But first, we're going to talk about something a little bit simpler. We're going to start simple and we're going to get a little bit harder as the video goes on. So, first, we want to talk about horizontal and vertical lines. So, if you take standard form, ax plus by equals 0, if you make a 0, well, what is 0 times x? That's 0. So if a is 0, you're just left with, whoops, that should be equals c. You just have by equals c. And if you divide by b on both sides, we get y equals c over b, or we write y equals b. So if a is 0, you get y equals lowercase b, y, and that's just some number, right? C over b, but that's just a number, so we call it lowercase b. So if you have y equals b, that is a horizontal line. Similarly, if we had made b 0, we would get x equals a, and that's just a vertical line. If you did not understand what I said over here on the left, that's fine. You don't need to know that to understand how to graph horizontal and vertical lines. It's just some background information about how equations of horizontal and vertical lines are made. So, here's what we need to know about horizontal and vertical lines. If we have y equals b, and b is just a number, right? This could be y equals 5, this could be y equals 1, we don't know, could be anything. We are going to cross the y-axis at that number. So if we have y equals 5, we're crossing the y-axis at 5. If we have y equals 1, we're crossing the y-axis at 1. Similarly, if I have x equals a, or x equals a number, this could be x equals 2, it could be x equals 6, don't know, doesn't matter, but we're going to cross the x-axis at that number. So if we have x equals 2, we're crossing the x-axis at 2. If we have x equals 6, we're crossing the x-axis at 6. Okay. And if we are crossing the x-axis, then our line will be vertical. If we are crossing the y-axis, our line will be horizontal. So that's an easy way for me to remember what's horizontal, what's vertical. Oh, I'm crossing the x-axis, so I'm going to be vertical. Yes. There's another way that you can think about it, which is y is equal to whatever this number is, could be 5, could be 1, whatever. Y is equal to b. X can be whatever it wants, because all that the equation tells us is y is equal to 1. X can be anything. So we could have 5, 1, we can have that point, we can have 0, 1, we can have 3, 1. X, the x coordinate, can be whatever it wants. We just need y to be equal to 1. So another way that I think about it that helps me is the x-axis. We're going to have a point along everywhere on the x-axis, but we just need to be at y equals 1. So that's another way that I think about it. X can be anything, but y is 1, and that's where the line comes from, is we have infinitely many points where y is 1. We just have different x coordinates. And the same thing for the vertical lines. Okay, wonderful. Now, let's go ahead and move on to our first example, graphing horizontal and vertical lines. So, they want us to graph y equals 4 and x equals -2. So, here's how I do this. y equals 4 means I'm crossing the y-axis. So if we have y equals 4, we're going to look at the y-axis, and we're going to go to 4. 1, 2, 3, 4. We're going to find 4 on the y-axis. Then, we're going to draw a line through it. The end. Graphed. That is the graph of y equals 4. It is a horizontal line at y equals 4. It crosses the y-axis at 4. Similarly, let's look at x equals -2. We have x equals -2. So I am going to find -2 on the x-axis, excuse me. -1, -2, and I am going to cross the x-axis at -2. And there you go. Done. Done with the problem. So, y equals crosses the y-axis. So these are horizontal lines. And x equals crosses the x-axis. So these are vertical lines. There you go. That's example 1. Let's check and see if we were right. For every value of x, the value of y is 4. We talked about that. X can be anything. Every value of x can be anything it wants, but y is 4. So we have a ton of points up here. And y can be anything it wants, but x is -2. So there we are. Wonderful. We did the same thing. Cool. Moving on. Some more vocab. So this vocab is going to help us work with standard form. Notice that we didn't really use standard form in example 1. We are going to use standard form in example 2. So in order to understand standard form, or to be able to graph in standard form, we need to know what x-intercept and y-intercept are. So if you think of an interception in football, right? If the quarterback throws an interception, what has happened? The other team caught the ball, right? The other team took the ball from you. So our guy was trying to come in and catch it, and then some other guy came in and sniped it. So the way that I think of it, as our team was going for the ball, so was the other team, but the other team took it right where the ball was. So I kind of think of it as an interception is where the two teams cross, or where the two teams come together. So an intercept in math is where lines cross, right? We have intersections, but we also have intercepts. The x-intercept is where the graph crosses the x-axis. The y-intercept is where the graph crosses the y-axis. And there you go. X-intercept is where does the graph cross the x-axis. The y-intercept is where does the graph cross the y-axis. Now, some more information about this. We can use these intercepts to graph equations because it only takes 2 points to make a line, right? I have a point here and a point here. I can draw a line in between them. And then I have a line. So, if I can find my y-intercept and my x-intercept, I can draw a line in between them. And there we go. There's the graph of my line. So what we're going to do in the next example is they're going to give us an equation, ax plus by equals c, and we need to find the y-intercept, find the x-intercept, and then we can draw a line between them, and we will have graphed. ax plus by equals c. So, a little bit more information about x and y-intercepts. The x-intercept of a graph is the x-coordinate of a point where the graph crosses the x-axis. We talked about that. It occurs when y is equal to 0. When y is equal to 0, how come? Why? Well, if we look at the x-intercept, notice it's along the x-axis. What does y equal when we are on the x-axis? I haven't gone up, I haven't gone down, I have stayed at 0. If I'm on the x-axis, y is 0. Similarly, if I'm on the y-axis, I haven't gone to the left, I haven't gone to the right, I have stayed at 0. So on the y-axis, x is 0. So the y-intercept occurs when x equals 0. This is very, very important because this is the key to finding the y-intercept and the x-intercept. So, to graph the linear equation, ax plus by equals c, so we know this is going to be a line, ax plus by equals c, we know that the graph is going to look like a line. In order to graph ax plus by equals c, find the intercepts and draw the line that passes through the two intercepts. So draw the points and, draw the points and connect the dots with the blue line, or just like the blue line in this picture. Okay, so to find the x-intercept, let y equal 0 and solve for x. To find the y-intercept, let x equal 0 and solve for y. This is the key. This is the key, right down here at the bottom. X equals 0, solve for y. Y equals 0, solve for x. This is how to find the intercepts. Once we find the intercepts, we just need to put them on the graph, and then we can draw the line. Okay, so you can think of this as like step 1, step 2. Find the intercepts, draw the line. All right. Now let's move on to our second example. We are going to use intercepts to graph 3x plus 4y equals 12. So remember, step 1, find the intercepts. Where are my points going to go that I need to connect to draw my line? Well, so to find the intercepts, I need to make x 0 and I need to make y 0. So it doesn't matter which one you do first. You can do whichever one you like first. So let's do x equals 0 first. So I'm going to take the 3x plus 4y equals 0, and instead of x, we're going to write 0, because x is 0. What is 3 times 0? 0. And, oh my goodness, this should not be 0, this should be 12. 3x plus 4y equals 12. I'm sorry. 3x plus 4y equals 12, just like it said in the problem. All right. Now, 3 times 0 is 0, plus 4y equals 12. So I need to solve for y. Well, the 0 can basically go away, right? If I have 0 plus 4y, that's just 4y. Now, how do I get y by itself? I have 4 times y, so I am going to divide by 4 on both sides. And we get y is equal to 12 divided by 4 is 3. So my y-intercept should be at 3. And in fact, let me graph that in red so it's easier to see. Y equals 3 is going to go at 3 on the y-axis, because the y-intercept is where the graph crosses the y-axis. Okay, perfect. Let's do the next one. Let's do y equal to 0. So we're going to take 3x plus 4y equals 12, but now y equals 0. So I have 3x plus 4 times 0 equals 12. And that leaves me with 3x equals 12, because the 4 times 0 is just 0, can go away. All right, how do I get x by itself? I can divide by 3 on both sides. 3 times x, opposite of multiplication, is division. So we have x equals 4. And, let me switch colors again. X equals 4. I'm going to put this on the x-axis. So there is 4 on the x-axis. And now, to graph, all I need is to connect these dots. That's not a very straight line. Let me fix that. Goodness, a ruler would help. There we go. That looks pretty straight. Okay. All right. There you go. We are graphing a linear equation, and that graph is a line. So it is the graph of a linear equation. And we are done. Awesome, awesome. Let's check and make sure that we were correct. Substitute y for 0, solve for x, x equals 4. Substitute x for 0 and solve for y, y equals 3. Look at that. Our graph looks just like theirs, so we are correct. Awesome. Okay. So that is all I have for you today. We graphed horizontal and vertical lines, and we graphed equations in standard form by finding the x-intercept and the y-intercept. So, what I'd like you to do now is rate yourself on a scale of 1 to 3. How well do you understand the learning target and the success criteria? Do you know what standard form is? Can you graph equations in standard form? Can you graph horizontal and vertical lines? How are you feeling about the learning target and the success criteria? If you're a 1, talk to your teacher, go to after-school tutoring. I'm in after-school tutoring. You can come see me. If you're a 2, try the homework. Make sure that you practice these skills. If you don't practice them, you might not remember them. You might not truly learn them without the practice to truly wrap your mind around what's going on. And if you're a 3, awesome. Reach out to your friends, reach out to your classmates, see if anybody needs help. Okay, awesome. These are some practice problems that you can do to practice the skills you've learned in this video. Let me hide my head for a second so that you can see all of the questions on this screen. We have example 2 and example 3. These questions also go hand in hand with example 2. And yeah, make sure that you do the problems that your teacher assigns as well, but these are the questions that match with the examples we've done in this video. And last but not least, we're going to do our launch just as usual. So today's launch comes from Maya Angelou, And she says, "My mission in life is not merely to survive, but to thrive." So, think about what it means to survive. If you're surviving, you're barely getting by. You're finding a way to keep living, but you're barely surviving. Like, you have the basic necessities. You have food, you have water, you have shelter, and that's it. You are surviving. If you are thriving, you have more than you need. You have, a nice roof over your head. You have plenty of food. You have, other things that you want besides the basic necessities. You have all this knowledge. You have maybe a college degree. You have other things that you want in life. So your mission should not merely be to survive, but to thrive. Now, should you be happy surviving? Sure, absolutely. Be happy with what you have. Don't be like, "Oh, I'm not thriving. I have a roof over my head, but I'm not thriving." Be thankful for what you have. But your goal or your mission in life, you probably want to thrive. You want to take nice vacations. You want to have a car that doesn't break down every time you drive it. You want to thrive. So, think about, what do you need in your life in order to thrive? What does thriving look like to you? Thriving can look different to different people. Some people are happy to have a roof over their head and a job that pays their bills. That is thriving for them. If that's thriving for you, awesome. That's fantastic. But define thrive for you. What would it look like for you to thrive? Do you want to be a lawyer that drives a Jaguar and wears fur coats? I don't know. What does thriving look like to you? And what do you need to do in order to thrive? Start now. Start thinking about it now. Start making a plan as to how you want to thrive. Because it's no fun working at McDonald's your whole life, You want to thrive. So, that is my launch for you today. Think about, what does thriving look like to you, and make a plan to get there today. Have a wonderful rest of your day, and thanks for listening to the launch. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.